You can start.
Good evening to one and all. I'm Sentulal Debarma, participant in this program and your coordinator for the session 17. As we have recently celebrated the Teachers' Day, and this program is about the faculty development program, so it would be relevant at the very outset to brief you all the eminent personality, Madan Mohan Malviya. Madan Mohan Malviya was born on December 25th, 1861, in an educated Orthodox Hindu family. Pandit Madan Mohan Malviya was a freedom fighter, an educationist, and a social reformer with a vision of independent and self-reliant India. Apart from holding the post of the President of Indian National Congress, he represented India along with Mahatma Gandhi at the very first Roundtable Conference in 1931. He is also the founder of the prestigious Banaras Hindu University at Varanasi. He made efforts for dismantling of caste and social barriers. For this, he even organized a group of 200 Dalits to demand the entry into the Kalaram temple on a Rath Yatra day. He is credited with the popular slogan Satyame Vijayate, that is, truth alone will win. This great personality was honored by printing a postage stamp in 1961. The Malviya National Institute of Technology, Jaipur, has been named after him. This philanthropist, also known as Mahamana, passed away in 1946. He has been honored with Bharat Ratna, India's highest civilian award, on 24 December 2014. So, as we begin this session, let us commemorate him and also put him as a role model. Let me now take this opportunity to introduce the resource person for this session, that is Dr. Sudipta Jha. Dr. Jha is an assistant professor, as already earlier introduced by Dibjyoti sir, in the Department of Economics in Vidyasagar University, Midnapur. She has completed her PhD in 2017 with the title Sectoral Interaction in Macroeconomy from Yadavpur University. She has served ICRA Limited Kolkata as a research assistant in its monetary research project under Professor Mehir Rashid from July 2007 to July 2010. She has been a guest lecturer from MBA department in Murshidabad College of Engineering and Technology from October 2010 to July 2011. She has also served as assistant professor under FDP scheme in Sirampur College from July 2011 to April 2012, and now currently works as an assistant professor in Vidyasagar University since April 2012. Her research areas are macroeconomic theory and international macroeconomics, and Indian macroeconomy theory and MFRIC. She has 2 international publications published by Emerald Publishing Limited, UK, and Euro-American Association of Economic Development Studies. 6 national publications, a book titled Inequality, Poverty, and Development in Backward Zones in India. She also has published several book chapters. In 2017-18, she has worked on a project titled Role and Effectiveness of Government Expenditure in Promoting the Development, a study on backward region of West Bengal, funded by UGC. She has also organized an UGC-sponsored Sweden National Seminar on Economic Development, Contemporary Issues. She has been awarded by Kalyani University for her outstanding performance in BSc and MSc Economics in the years 2005 and 2007, respectively. With this, Dr. Sudipta, ma'am, may I now request you to take over the session, please?
Thank you, Sentu, and I welcome again Sudipta Madam for the session.
Okay, so thank you. Thank you, Dr. Chaudhary, and thank you, Dev Borma. So now, can I start?
Yes, madam, you can start.
Okay, thank you. So I'm switching off my video to have a better bandwidth. So if you want, then I can switch it on, okay?
Sure.
So, hello participants. Very good afternoon to you all. And without wasting much time, let me start today what is our topic, because in general class we usually take 2 months to discuss all these topics together, but now we only have 2 hours, so we must not waste our time much. Okay, so what we are good evening to you all. So please wait, we have to open the PPT where I shall share it. Okay, so what was in our brochure that today we are going to discuss Ganser causality analysis, basics of VAR, VECM, and co-integration using GRETL or reviews. You all must have seen it. And now, good morning, good afternoon. And now we will just rearrange those topics for our convenience. And as I don't know the software GRETL, so I shall be here only using eViews to discuss first the Ganser causality, then we will discuss VAR, and just changing slightly the order. We'll first discuss co-integration and then introduce the term ECM, rather VECM. ECM is error correction mechanism. So you must first know what is ECM, and then we can easily understand what is VECM. VECM is just an extension of ECM. It is vector error correction model. Okay, so we'll come to that. But before I proceed, I must let you remind that we are in a multivariate framework now, bivariate or multivariate. And we have already become familiar with the properties of a time series in a univariate framework in our previous classes. And like we now know that what a time series is, what do you mean by stationary and non-stationary time series, integrate series with integrated of different orders like I1, I0, I2, whatever be it. If it is I0, then it is called a stationary series, and if it is I1, then we need to differentiate the series once to have to make it stationary. If it is I2, then we have to differentiate twice. We all know this, I think. And also we must know that what is an autoregressive process, because today we are going to discuss vector autoregression. So we must know what is an autoregressive process in a univariate framework. And also actually time series, in time series, it is the dynamic structure of economy, or maybe for a variable. We are analyzing the dynamic structure. So it's very natural or is general to think that when a shock will hit the economy or a particular variable, then it cannot happen anything instantaneously and evaporate. Okay, you have to give time to adjust the economy or to the variable. So autoregression process is very natural for the time series phenomenon. And also most importantly, we must have now know that why we take usually log of a time series to analyze that data. Because as I have said that we are in a bivariate or multivariate framework, we must also, and at the first stage, we must also know that we are in a linear framework also. So whatever we will do, every model is actually a linear model. So log actually makes our variable more or less linear. Okay, in general, the time series we deal with are not linear in nature, but if you take log of it, it will linearize the series. So and also by taking log, you can also reduce the order of integration. If it is I2, then if you take a log, then naturally it is expected that it will become I1. So these are the advantages we use to take log of a series. So these are the first things. Now, with this understanding, today we are going to discuss about the relationship among 2 or more variables, or 2 or more time series rather. And we will use some techniques, that is the VAR, Ganser causality, VECM, co-integration, whatever be it, to understand the co-movement, the causal effects of the variable. Okay, So today we will try to address the problem of how to frame a model which involves more than one time series data. And for example, we can think that if you are given GDP data series and investment data series, that is the GDP and GFCF, gross fixed capital formation for the post-liberalization period of India. Say for India, if you see the data, you will find it is from 1991-92 to say 2021-22. For India, this is the financial year data is available, but if you take any data from the international agencies like...
Madam, sorry to interrupt. Like
yes,
whether
yes,
you're
yes.
showing the slide?
Yeah. Definitely. I shall show.
But the slide is not like visible.
Okay. I'm showing it.
Okay.
I'm just for the introductory part.
Okay.
I didn't make any slides, so okay. I shall show it definitely. So if we are going, if we are given the data of the GDP and the investment for the India, then our task is to analyze those data and comment on the relationship. If people ask that what kind of relationship you can see from these data, what we first should do, now we now know at least for today, we know that first we have to check the stationarity or the unit root. We have to test the unit root test to know that whether these series are stationary or not. Because if these series are non-stationary, which is very general to expect, so if the two or more series are non-stationary, then their relation may come out to be spurious. Now, you have to remember that for investment and the income, the example I have given is quite expected that they have a meaningful relation between them. Okay, we're not denying that fact. But if you try to find out that relationship through simple, say, correlation, or if you run a regression to know how much it depends on the other one, it may come out to be spurious in the sense that the relationship may not be as strong as we find it. Okay. That is, we are not saying that any statistical relationship between two non-stationary data is spurious. No. If there is a theoretical justification behind the relationship, then of course the statistical relationship is also valid. But we can suspect, or there is ample reason to suspect the accuracy, the strength of the relationship we find. So we must not rely on these relationships unless we use sufficient filters. Okay, we have to make this series independent of time. Okay, we have to eliminate the common factors that is affecting both to find out the true relationship between them, because we are not interested in that third factor which is affecting GDP and investment. We are interested to know, in the absence of that third factor, how investment is going to affect the GDP or the other way around. Okay. So that's why we need to know whether this series are stationary or non-stationary. If we have stationary series, then some measures or most of the econometric tools you can apply without any fear or without any doubt. It is going to be yield a fair result. But if it is non-stationary, then you have to be more careful. We will go to that, which kind of techniques at that time we can apply. Okay. And the problem becomes very clearing if you think of the examples like India's GDP, and now a more contemporary example would be Russia's military spending. Okay, if you're now going to regress, it will give you a good, probably it will give you a very good, very strong positive correlation between them. Even if you regress Chinese population with India's GDP, you'll get a strong relationship. Okay, and not only with these series which are actually increasing over time. If you take, say, Japanese price level, because you can have a very prolonged period of deflation there. With India's GDP, you probably will get a strong negative relationship. But these are basically nonsense relationships, isn't it? So let me show that how a non-stationary series actually gives these types of nonsense results, where these series when we made it stationary, the nonsenseness gets reduced. Okay, so that's why I have not first show you this slide. Let me share my whole screen so that let me share the screen. For not screen, okay, so that you can see what I shall do in the e-view. Okay, please tell me if you have any problem in seeing the presentation. Okay, I'm opening the e-view. So are you all seeing my screen? Is it visible to you all?
No,
Not
ma'am.
yet, madam.
No,
No.
ma'am.
Showing started sharing screen.
Okay,
Yeah,
okay.
now it came.
Now it's okay. So let me open an e-views file. I have already said it is a BRIC for BRIC countries. I have some data up to 2019. Okay, these example I'm taking these example because now we will we can see that how between two different countries the data, if without checking their stationarity, say simply we try to find out the correlation, we can get high correlation. Say with the so say FDI in Brazil, that is LNFDI BR, it is for Brazil. And let me check this relation with GDP of China. Okay, so I have selected these two series and then open as group, and probably the proc Iceland, no. Covariance analysis, and let us see the correlation, okay, with the probability. So you can see how strong is the correlation. It's 0.88, okay, and it's also statistically valid. They are saying that statistically valid, but actually it's nonsense. With the rise in the GDP in China, you cannot expect any simultaneous rise in the FDI in the Brazil or other way around. It must not be the case. So now let me check how was this series. Okay, so for FDI Brazil, unit root test. Okay, so first it is the augmented Dickey-Fuller test, and we're checking it at level and with the intercept term. Okay, and lag will be selected, maximum is 6, and the SIC criteria will select the optimal lag automatically. So now we can see that it is non-stationary. You all know that how to check stationarity, non-stationarity. Okay, so it is non-stationary. So again, the unit root test, whether C including a trend can make it stationary or not. Yeah, it is stationary. It is trend stationary. Okay, but at level these are non-stationary. Now GDP of China. Sorry. It is how it looks. I have taken the log of the GDP of China. So as I was telling you that how it make it linear. Okay. Now unit root test at level, simple intercept. So it is non-stationary. You can see the probability, the t statistics. It must be higher than these critical values. Okay. So unit root test. Let me see whether including a trend can make it stationary. It is TSP series or not. No, it is again not. So let us take the first difference of it. No, 0.60 is not. So it is not I1, okay? Integrated of, or actually a single differencing will not make it stationary. So second difference with intercept, no trend. Now it is stationary. So Chinese GDP is I2, and but we find the what was that? Probably Brazil's FDI was I1. So these two non-stationary time series, because of their non-stationarity, we are having such a high correlation between them, when actually we know that these are nonsense or spurious relations. So now let us check, if I take the stationary counterpart of this series, okay, what happens? So we have to differentiate twice, and for Brazil we have to differentiate one, or you can also just including a trend can make it stationary, but we are not going to estimate the trend on come, and then actually taking the residuals will give you the stationary part of that series. It's difficult, so let us differentiate out. Okay, so from quick group statistics, correlation in between, say, D, the first difference, B of, then again the second difference, B and D of Chinese. Okay, so we have to give two brackets in the last, and we need T of, what was that? FDI, LN FDI Brazil. So LN FDI Brazil. Okay. LN China is not defined. Why it is not defined? Let me do it once again. Correlations. E is coming. T LN LN GDP China. GDP. Okay. This is for the first, and this is for the second difference. And D LN FDI underscore Brazil. Okay. I think I have written it properly. Okay. So let us see. Yes. So now you can see the correlation is reduced to 0.12. So if a relationship is spurious with the stationary data set, it comes out to be spurious. Okay, but for the non-stationary data set, we may have estimate which is showing that yeah, these are highly correlated, but it may not be the case. Okay, so that's why. So okay, we first check that whether our data series are stationary or not. Okay, this is the first thing we have to do. If we have stationary data set, then we can apply most of the techniques until now we have studied, or some definitely we can apply these Ganser causality, VAR, or simple Oilless regression. We can apply these series, but if these are not stationary, then we cannot apply directly the OLS, VAR, or the Ganser causality types of analysis or estimation procedure. Because if we run OLS, I have just shown you what happens when two data series are non-stationary and what happens to correlation. It is very much related with the regression also. So for Oilless regression, in general, it will give a high R square. So the rule of thumb is, if you find that with the two series, you don't know, say you don't know whether series are stationary or not, or you know that these are non-stationary data, yet you are trying to regress a particular variable on another variable, and if you find that R squared to be higher than DW statistics, Darwin-Watson statistics, So you will generally, with this Fourier's relation, we have high R square, low DW statistic. We have high T value that is close to 4 or more than that, if not. So these are the indications that you are running a spurious relation, you are having a spurious relation. Okay. So you should not apply Oilless regression when you have non-stationary data. You must not apply the Granzer causality, the VAR in the non-stationary data. You have to make it stationary. If these series, in general, the macroeconomic series we confront are non-stationary in nature. So our first task is to see whether it is stationary or non-stationary. Now, if it's stationary, then or if we find that the series are non-stationary, then first we have to make them stationary. If they are TSP series, then we train the series and check the residual to make it stationary. If these are DSP series, the series are I1. Most of the time we get I1. Then differentiate the series and take the stationary counterpart. Okay. Then apply the Granzer causality, VAR, Oilless, etc. Okay. But actually, in time of detrending or differencing, we actually lose some informations also. So to retain all the informations we have, we sometimes or most of the times we prefer to treat the non-stationary data with some special techniques to deal with. Those techniques are, some of the techniques are co-integration and the error correction mechanism, or the VECM, vector error correction mechanism. But first we are going to discuss the stationary series and the techniques which we can directly apply to the stationary series. Okay, the Granzer causality. So up to now we are talking about the correlation. Okay, but Granzer causality is actually talking about the cause and effect. That is, when saying that we are seeing the relationship between GDP and the investment, we are saying that how the linear association in between these two series. So it's 80%. So a strong correlation we have. But from that series, even from the regression also, we cannot say that whether GDP is causing more. If you are having more of the GDP nowadays, is it causing the investments to be more, or actually investment, a higher investment is causing higher GDP we are having? So like this, you can think of the consumption or investment. You can think of the FDI and GDP. We are seeing that whether FDI is causing higher GDP growth, that is a country is receiving more of the FDI, so it is having higher GDP. Is it the relation, or actually the opposite? Country is actually showing actually running with a high growth phase, in the high growth phase, so it is attracting more FDI. So it is not always true that FDI is causing GDP. GDP may also cause FDI. We don't know beforehand. So to check this possibility, whether the particular variable is causing or the other variable is causing this particular variable, we actually test or actually apply the Granzer causality test to those series. So it's a bivariate framework. In general, Granzer causality test is applied to a bivariate framework. We pairwise we test. Okay, you can have 16 to 17 data sets. Okay, but you have to check. You have to apply this technique in a bivariate way. Okay, so how do we check? Actually, let us build a model. Model one is showing that ln xt, that is log of x. Okay, so I will not every time repeat the log term. So whenever I'm saying xt, you just mean it as taken log of x. Okay. Because this model is also a linear model. Okay, so we have to linearize our data. So taking log is if not mandatory, it is desirable. Okay, so xt I have written is a function of its own values. That is, here I have written, you can see it. Okay, xt minus 1. Also the regressive process. we must have now know that what is an autoregressive process, that a particular variable depends on its own past values. Okay, so xt depends on xt minus 1, xt minus 2, xt minus 3, and additionally I have included another variable, that is yt, in that particular regression equation. Okay, so xt, I'm assuming that xt is not only depending on its own past values, it is also depending on the past values of y. Okay, yt minus 1, yt minus 2, and like this. Now, if we find in this through this regression that all the betas, okay, beta 1 1 I, that is beta 1 1 1 for the first lag, beta 1 1 2, that is for the second lag of yt. So all these betas are come out to be 0. Okay, that means that y have no role in predicting the xt variable. So if past values of a particular variable cannot predict or fails to predict a variable we are encountering, then we can say that yt is not a cause of xt. Okay? But we must keep in our mind that Ganser causality is actually a kind of predictive causality. Causality by its mean is a very big term, okay? But Ganser causality actually captures only the predictive part of the causal effect, okay? So in the Ganser causality test, we only test whether a variable can predict another variable or not. If the past values of a variable can predict another variable, then we say that the variable whose past values we have taken is Ganser causing the other value. So here, yt is a Ganser cause of xt if we find these betas to be significantly different from 0. Okay. Similarly, in model 2, we can test that whether xt of xt can predict the yt. Okay. So, due to the autoregressive nature of a time series, a value the present value of a variable can be predicted based upon its past value. Okay, this regression we can always run. But in that regression, if we include another variable and the predictive power of that regression increases, then we can say that this additional variable we have included is a genuine of the other variable. Okay, so actually for the Ganser causality test, ultimately we find out this F ratio. Okay, what is this F ratio? It is based upon the RSSR, that is the residual sum of squares, simply the UI, the part which we cannot explain for regression analysis. R is restricted and UR written here is for unrestricted. So what is a restricted regression? If we regress a particular variable only upon its own past values, then we call it a restricted regression. So think that we have a model of ln xt is equal to an intercept term theta 1 1, and then only this part is there. Okay. And we done a regression and we have an naturally ui square hat. Okay, so that is RSSR. Now we run another regression, additionally including the past values of y in that regression. Okay, again we will have some RSS, residual sum of squares. Some part we cannot explain definitely in that case also, but if that part is lower, okay, lower in value than the restricted part, then definitely we can say that we have improved our model in predicting xt. Okay, so in that case the value of a will get rise because in the denominator we have RSSUR. Okay, so if it is get reduced, that is we have made a good model, Okay, the residual sum of square will be lower, and it is in the numerator is with a negative sign. So in any case, if our unrestricted model is better, RSS UR will be lower, so we'll have a higher F, okay, and that will be significant. So we test in the Ganser causality test whether we have a significant F or not. If our F is significant, the probability is very low, then we can say that a particular variable is causing another variable. Okay, and if we have a lower value of F, the probability will be higher. So we will say that this variable does not cause the another variable. So null hypothesis of the Ganser causality test is no Ganser causality. That is, xt variable is not causing yt variable. Okay. Now here the deltas were given. Okay. Why it is given? Because we are assuming that x and y are DSP I1 series. Okay. So with the first difference, it will be stationary. Then only you can apply the Ganser causality test. If you apply this test with the non-stationary data, you may have spurious result. Okay, this test is designed for the stationary series because these are all Oilless technique we're talking about, and Oilless is very good for the stationary series, but not for the non-stationary series. Okay, so you have to keep in mind that if you want to apply Ganser causality to any data set, you have to first check whether these are stationary or non-stationary. If stationary, you can directly apply. If non-stationary, then you have to first make them series stationary and then apply. Okay, and the null of the test is delta xt here. A particular variable is not causing. Okay, so you have to reject it. You have to have a higher value of n and lower probability. Okay, so now let us check in the e-views how we measure it. Okay. So let me delete it. So with this data set, we can check for a particular country. Hello?
Madam, data set is not visible.
Data set is not visible. Can you is it visible? A e-views window?
E-views window is not visible. PPT is visible.
PPT is visible, but I have okay. Let me check. Okay. Now here from this I have to Now is it visible? Window? E-views
Yes,
window?
ma'am. Yes, ma'am.
So let us check, say, for India. So for India, it is the credit. D credit means domestic credit. Okay. The series for India's domestic credit. The bank, usually the commercial banks, give the domestic credit. So for India, we have domestic credit series, and we have the series for 1991 to 2019. Okay, and let me show you. These are the series. Okay, you can see the graph also. Okay, so domestic credit for India. Okay, and the Ganser causality. So let me check whether in India for export. Okay, FDI India, and then also GDP for India. Okay, these are the 4 variables for India. We have domestic credit series, we have export series, we have FDI series, and we have GDP. Okay, so let us check which one is causing another, or whether at all they are causing each other or not. Okay, so open as a group, I think we have to, and then from the quick group statistics, Ganser causality test. But it is expected that all these series are I1. I have not checked, I have not shown you, but expected it is. As far as I can remember the data, these are all I1. So let me check the different series. Okay, but in each time you should check, because it may be trend stationary, it may be a DSP series, so you have to be careful about that. Let me just show you. Okay. lags to it's a very important thing. Here, these are the yearly data. So I think the 2 lags are sufficient. But this is actually, you must not be subjective in this case. You have to check. And actually, if you put the wrong lags, so then your results also may come out to be wrong, or actually it is sensitive to these lags you are including. So based on some criteria, information criteria, you should choose how much lag to be included or not. So the best thing is to first estimate a VAR. I'm just coming to that. So this time I'm just guessing that 2 will be sufficient. But in each time, whenever you have a bivariate or multivariate framework, you have to choose the number of lags. You first estimate a VAR analysis, and then from the VAR, you can find that the optimal lag. I will come to that, okay? So for this time, you just assume that the 2 lags is sufficient, okay? I can show you what happens if we take 3 or 4 lags. Yes, delete untitled group, yes. So that, so you can see that now we have taken 4 variables, but the results are coming pairwise, okay? So the first thing, it is showing that DLN export IN, that is, it implies that actually export growth. LN export, and if you first difference, you take the first difference, that is DLN export is actually the export growth, okay? So whether growth in export causing the domestic credit or not. If you are having a more export, you can think that domestic credit may get rise. I don't know whether it's true or not. I don't think there is much theoretical basis for this result, but whatever. Or the second one is more theoretically plausible. That is whether the domestic credit, growth in the domestic credit causing the growth of the export or not, okay? But from the F statistics, we can see this is the probabilities, okay? That actually these are not causing, that is neither export is causing domestic credit or domestic credit is not causing the export. Only in case of this is very important result. Export, that is the growth in the export is actually causing, we can reject the null hype. Null is does not Ganser cause, okay? So that in that case, you can see the F is relatively higher than the other Fs, okay? And the probability is 0.06, that is at the 10% level of significance. We can say that export credit or the growth of the export, is actually causing the growth of the FDI. It means if you are having a higher export growth, you can expect that you will have a higher FDI inflow. Okay, so for India, what we have found for the post-liberalization period, we are taking that export is causing, or we can say that export growth is a predictive cause of the FDI growth. Okay. And in another case, we have found the Ganser causality, that is GDP. Here, the null is GDP, actually DLN GDP, that is the growth of the GDP, does not Ganser cause DLN export, that is the growth of the export. And we can reject it also at the 4, that is the 5% level of significance. We can reject the hypothesis, and we can, so we are accepting that growth in the GDP is actually causing growth in the export for India. Okay. And in another case, we have also at the 10% level of significance, we can say that growth in the GDP, DLN GDP implies growth in the GDP, is causing, because we are rejecting the null, does not cause, we are rejecting it, we are accepting the alternative, so it is causing the FDI in India. Okay. So what was I was trying to say? It is always not true that you're having higher FDI, so you're having higher GDP. No, it may not be the case. In general, we have the opposite causality. If you are having, or if you are performing better, if your GDP is higher, you can attract more FDI. Okay. So Ganser causality test we can use for these kinds of analysis. Okay. So what was causing, and what was the effect? But in Ganser causality, we cannot find the effect. We are finding the causal, what is the causal variable, but how much it is affecting, okay, we don't know. From this analysis, we cannot say. And as it is a pairwise analysis, so it may happen that actually a third variable is there in between GDP and FDI, which is the actual cause of FDI. And actually GDP is affecting that particular variable. Rate of interest we can think of. We are just assuming that if in between there is a variable like rate of interest, the higher GDP is also actually raising the demand for domestic loans or like that. So we are having higher rate of interest, and so this higher rate of interest attracting more FDI. It may happen, but we cannot say anything from this analysis. Okay. So this analysis is just a initial part of a research. Okay, if you want to analyze the proper channel, the whole structure, if you want to understand the whole structure, whole picture, you want to complete the circuit of logic, then Granzer causality will not suffice. Okay? To make our model more robust, to include more of the variables into it, to understand the exact causal relationship, we must go to the VAR, vector auto regression model. Okay. So up to now, do you have understand that what Granzer causality test is and how to perform this test? Can I proceed to VAR?
Ma'am, I have a question.
Yeah.
Ma'am, is there can be there any negative or positive causality? Means
from the Granzer causality test, we cannot say. Okay. Granzer causality can only say that whether a past values of a particular variable, say GDP growth, is causing FDI or not. It can predict the FDI flows or not. Okay. Now, if you want to see the exact relations, how the exact relationship is, you have to estimate a VAR, VAR, that is vector auto regression. Okay. That is coming. Okay.
Ma'am, actually, I joined a bit late, so I just wanted to confirm, is the stationary of the data the only condition for applying
Yeah,
Granzer
definitely. You have these data we are using in a Granzer causality test must be stationary to have a non-spurious result. If you want a robust result from the Granzer causality test, your data must be stationary. Okay.
Yes, ma'am. That's it, or any other thing is to be checked?
And of course, the lags. Okay, I have not shown that how to check the optimal lag. Okay, here I have taken just 2 lags, but actually the results are sensible to the number of lags. Okay.
Okay,
so
ma'am.
if you take fewer lags, your results may change. Okay. So
Okay,
now I
thank you,
will
ma'am.
show during the VAR analysis how to check the optimal lag. What should be the optimal lag or not? Okay.
Excuse me.
Noted, ma'am.
Okay. Yes. Anyone else?
Yeah, I have written in the chat box. Is it only applicable on macro data? Can be applied on data as well?
You have written that. Is it only applicable to? No. It can be any data.
Okay.
And with me only macro data. Okay. So that's why I'm showing it. Okay.
Yeah. Okay.
Any between 2 data where you can expect some causal effects are there. Okay.
Yeah.
Whenever you are applying any technique, you must be clear in your head that you must have a plausible theory behind it. Okay. If you have a theory, then you must check it. Okay. Okay. So now coming to the VAR. So let me first show you how the VAR model looks like empirically. Then we will go to the theory, because the theory a bit difficult. Not difficult. So it's complicated. So from this, so let us say with these 4 data, we can estimate a VAR. Okay. Quick group statistics. No, estimate VAR. Okay. So with all these data, LN export of India. You want to see India or any other country? Say, okay, India. India. ELN export of India D ln FDI of India and D ln GDP of. Okay. So we are estimating unrestricted var, the estimation samples from 1991 to 2019. And first we are taking the 2 lakhs. Okay. It is given an exogenous variable is C, that is a constant. In each of the regression equation, we will have a constant. Now first. Okay. So this is how a var model looks like. So each of the columns are for a variable. So the first column is of India's domestic credit. Okay. So the first column is a regression result where the domestic credit of India is regressed upon domestic credit. We have taken the 2 lakhs. So the first and second leg of domestic credit, it is the auto-regressive part. And then we are also including in that regression ln export for the 2 lakhs, FDI for the 2 lakhs, and GDP. These are our growth. Okay, P ln GDP. So growth of the GDP for the 2 lakhs, and in the last we will have a constant. This is the constant, and also the other statistics are given here. Okay. So how is the R square, adjusted R square, the F statistics, how the model is good or not, etc. Okay. These are the things. And for the second column, we are having log of export, D ln export. That is the how we can explain the, if we try to explain the India's export growth with these variables, this will be the regression look like. Okay. So we have that. So in the second column, the growth of the export is the dependent variable, and the independent variables are now credit, domestic credit, export, FDI, GDP. Third is for the growth of FDI, and the fourth is for growth rate, that is the GDP growth rate of India. So whether we can explain GDP growth rate of India by these variables or not, we can check. Okay. And for the R square values, you can see that the first one where we are trying to explaining the LND credit, that is the domestic credit, this regression is actually can explain 60% of the variation in the domestic credit of India. So it's a good result. But for GDP, that is the growth rate of GDP, these variables, that is GDP's past value is of course there, and other variables are there, but together they can only explain 31% of the variation in the GDP growth. Okay. And this is for ln export, I think. So it is 35, and it is for FDI, it can explain 46%. Okay. And from the F statistics, we can see that the only this F is higher. Okay. And these Fs are, I don't think, will come out to be significant. Okay. So now we have to take each and every variable where the how. Now someone was asking that what was the effect, positive or negative? Okay. So from the sign of this coefficient, we can find it out. Okay. So now you can see that past values of FDI is affecting domestic credit negatively. Okay. But actually these coefficient is not statistically significant. How do you know? Because in the third bracket, the T statistics are given. Okay. So for a data, it's a rule of thumb that if you have an observation more than 30, then you can expect 1.6 or 1.7. If the T values are 1.6 or 1.7, then you have the coefficient. You can say that it is significant at the 5% level of significance. So we will try to find it out that which coefficient is having a T statistic 1.6 or more than that. Okay. You can see that for the credit equation, domestic credit, when you are trying to explain the domestic credit for India, the second lag. Domestic rate, its own second lag is affecting it positively. Naturally, it will affect positively, and it is significant. The t-value is 3.25. So it is actually, it will become probably in 1% level of significance. Okay. Export, it is becoming at, I think, it would be 10% level of significance. Okay. It is close to 1.6, but of course not. FDI is not a good cause. Oh, no. The second lag of FDI is affecting domestic credit positively, and it is significant at the 5% level of significance. Okay. And of course, the first lag of GDP is affecting it positively, and it is close to 5%. I think it will be come out to be 7 or 8% level of significance. Okay. So this is the equation for domestic credit. Now, if we see the GDP series, okay, whether we are able to explain the growth of the GDP for India with these data or not, we can see that none of the variable is becoming significant at the 5% level of significance, isn't it? Only the GDP's past value is actually explaining in a significant way the current GDP. So these variables are not a very good variable to predict or to affect the domestic growth rate of India. And these kinds of results we have found in Ganser causality test also. There was no variable causing GDP, but somehow GDP was causing the other variables like domestic credit. We have in the FDI, we have also found GDP to be significant. Yeah, it is 1.7 here also, isn't it? So VAR is an extension of a more rigorous model for the Ganser causality test. And from the Ganser causality test, you can also find in the VAR framework, you can also find the Ganser causality test. Okay. So this is the basics of VAR, that is vector auto regression. Now we are going to the
Ma'am,
yes.
if my one lag is having positive influence and
Very
another
difficult to interpret. Yeah, that's the problem in VAR. And the first lag is negative. Yeah, it's a genuine question.
And
But
both
we
are
can-
significant.
If both, now
If both
for
are
this
significant,
equation, it doesn't matter.
no.
Okay. Yes,
If
but
both,
yeah, it's difficult to interpret. Actually, VAR is a theoretic model. Okay, there is no a priori theory we can think of before we are estimating VAR. Actually, Christopher A. Sim first introduced this concept, and actually he wanted to make it a theoretic because according to him, we should not make a particular variable a priori independent and another dependent, because we don't know actually how the economy reacts. So here you can see that every variable is endogenous. Every variable at some point of time is becoming dependent variable, and every other variable at some point of time becoming independent variable. Okay. So actually we are not having any a priori theory to think whether these should whether this should be positive or negative. How we can explain, we don't know. And this theoretic nature is a big problem in analyzing VAR. And sometimes, if here we have only taken 2 lags, if it becomes 3 or 4, the problem you are asking makes actually become more glaring, that for the first 2 lag you are having positive relation, for the second 2 we have negative, or positive negative may alternate. Okay, so it depends upon the researcher that how do you explain. It's difficult. We don't have any econometric technique to make it more user friendly, or to make it in our favor, that let us create a model which will be very easy to interpret. So it's a problem in VAR, so you have to be careful.
Ma'am, can I interpret in this way that the lags have mixed effect over the dependent variable?
Sometimes it's plausible that when say rate of interest, for rate of interest, you can think in this way. The say sudden rise in rate of interest is actually affecting the investment in a negative way. Okay, because cost of funds is increasing, or whatever it be. But after some lag in the economy, you can think in this line that with the rise in rate of interest, we will have more savings. People will deposit their money in the banks. So banks will have more of the loanable funds. So at that time, as an easier condition, you can have more loan for your investment. So even if the rate of interest is high, at some days after, with some quarter to adjust, you can have more investment in the economy. So if in that case, if you in your bar analysis, you find that in the first lag, the rate of interest and the investment is having a negative relationship, and then after some lag, it is getting positive. You may think in this line, okay? So you have to think over it, how the relationship should be, or whether whatever I am finding, it is going with the it can be explained with a plausible theory or not. Okay, sometimes you will find a theory like this. You have to be innovative in that sense, and sometimes your statistical result may also be wrong. Okay, lots of diagnostic checks are yet to be done for this model, whether you should believe in this model or not. So that's the question. It's not that the regression they are giving the results is absolutely correct. No. First of all, we have to check the lags. Okay, whether we have taken the optimal number of lags or not. And then, even if you have taken the optimal number of lags, then you have to check whether the residuals of this system is actually free from the autocorrelation. We have to do the LM test, whether the residuals are normal. We have to perform the JB Jog-Bella test. We have to see whether the residuals are homocharacteristics or not. Okay, so after these kind of diagnostic tests, and whether the model is stable or not. Okay, so these things we will show how to do. And after checking all the diagnostic tests, if we find these kind of results which is difficult to interpret, then either you have to be innovative, okay, or otherwise you have to you are not convinced with these results. It may be the case that the researcher is not convinced with the result. You don't have any theory to explain this, okay, then you have to re-estimate your model. You have to include another variable. You have to exclude a particular variable, which is very disturbing. Okay, so we actually in that case we can say that this variable is actually creating a noise in this variable in this model. Okay, so it depends upon you, your data, your theory, okay, your period of analysis. Okay, so there is no straightforward answer to this question, but it's a very good question. Okay, and it is actually the very common difficulty in explaining or analyzing in the bar. Okay, when you are trying to analyze your data in the bar, so these are the very common problem usually researchers face. Okay.
Yes, ma'am.
May I proceed?
Ma'am, normality of residuals is also to be checked.
Yes, definitely.
But ma'am, supposingly we are working on stock market data, so we don't get that kind of normality. So in that case, we cannot apply all these tests.
You have to apply. Then if this model may not fit your data, so you have to go for another model. Okay, it's not that for every data VAR is a good model. No, okay. Depending on, actually I will come to the theoretical part of vector autoregression. Then we can understand that when VAR is a good model, for which kinds of variable or which kinds of relationship VAR is a good model. Not for everything you cannot apply VAR. Okay. Now,
stationary, right?
yes. Hello.
For this data need to be stationary, right?
And definitely. Otherwise, we will not have a stationary. The model will not be stable. Okay, I will also show you how to check. Okay, you just wait. Okay, please wait for a minute. Okay, so now first see how to find the optimal lag. Okay, so lag length criteria. Okay, from the lag structure you have to go to the lag length criteria, and also the AR roots graph. I can show you that whether model is stable or not. Okay, so if these roots are lying within these unitary circle, so then our model is stable. Okay, this is a particular kind of stability check. We will come to it later, lag length criteria. So let us include 4 lags. Okay, so it will actually estimate all the equations including 4, 3, 2, 1 lags, and then it will say that which one is optimal for you or for your data. How to find the optimality? These are the criteria. Okay, and the less number it is, more information it is containing. So we will try to find out which one is the with the lowest value, and the star are also given for your convenience. So this particular FPE, final predictor error, these are all different types of criterion. So we say it var lag order selection criteria. Okay, these are the criterion, and the most common criteria is the AIC, SC, HQ is also some used. Okay, and you can see that different criterion are suggesting different lags. So it's another practical problem you may confront. Okay, in most of the cases we have usually we find that most of the criterion are suggesting same number of lags to be included, or they're saying that it must be 1 or 2 or 3. Most of the cases we find the optimum number of lags equal. But in this case, this is LR. It is saying that 2 will be optimal lag. Okay. It is saying that 2. AIC is saying 4 is the optimal lag. SC is saying 0 is the optimal lag. You need not include any lags. And HQ is saying the 4 is the optimal lag. So in this case also, it depends upon you, on the researcher, how many number of lags you would like to include. So you can take a trial and error method that you first take the 4 number of lags and then see whether the results are actually going with your theory or not. Then try 3 and see whether it is becoming more theoretically compatible or not. And in this way, you decide. But in most of the cases, we get similar number of lags suggested by the most of the criterion. Okay. Actually, we have abruptly taken these 4 variables. Okay. These 4 variables should not come along as a group, because in the var you should take all the relevant variables together. Okay, so you must take the variables, you must choose the group of variables very carefully. The most related variables we should take, and we should eliminate which is not so related, because in the var actually we are estimating so many numbers of parameters. So you always have a problem of degrees of freedom. Okay, you have a fewer independent observations left with. So in var, choosing the number of variables and number of lags is very important. So you should not take abruptly whatever data you have in a var. Okay, before creating a group to be estimated in a var, you should be careful about the variables you were taking. We are here taking abruptly some 4 variables. Okay, but we should have the other variables, and we should eliminate some variables from this and include the others. Because GDP, if you are having GDP, then without having investment, we are just taking FDI or the domestic credit, but we are not having included the real investment. Okay, so this is not a good model theoretically also. So now with this, I am going again, delete var. No. Keep it here, representation, sorry. Estimated output. Okay. So now I'm going again to the slide. It is the bar model. Okay, it is a handwritten note because it's very difficult to put all these equations in a slide. So I find it more easier to write it on a paper and then take a photo of it. So we have taken 2 variables, x and y, xt and y times, it is definitely xt and y. And actually, in the first equation is for S bar. What is S bar? It is structural bar. Structural bar means it actually tries to explain the structure of the economy. Okay, and we believe if we have a belief that xt and yt are simultaneously affecting each other, okay, then we should make this type of S bar, structural bar, where yt and xt are simultaneously affecting each other. The relation between yt and xt, the simultaneous relation, is captured through A12. Okay, a rise in xt will be transmitted to yt immediately through A1. Okay, and then the autoregressive part. Yt definitely depend on the past values of yt. We are taken one lag on, okay, for the simplicity. So that it is written S bar 1. 1 is the lag, okay. And then also, if the present value of xt can affect you, then definitely past values of xt will have an effect on you. So it is captured through beta 1, 2. And UYT is simply the innovations, a shock to the economy. We always have this unpredictable part. Okay, we must improve because we do not know the whole economy. We cannot model it. So some parts are there that is unexplained and that is captured through UYT. Similarly, the xt variable can be represented through the second equation, where yt, the instantaneous effect of yt on xt, is captured through A12, and then xt is depending on its own past value and of course past values of yt. Okay, so now in matrix form, if we write the equation, then it will become, the first is the A matrix, and then xt. Xt is a vector comprising of the two variables yt and small xt. Okay, you can name it zt or whatever you want. So A, the matrix A is very important. It is actually capturing the contemporaneous relation between xt and yt. It is the most difficult part to estimate. We cannot directly estimate these contemporaneous effects. Okay, this is the simultaneity. When actually VAR is applicable, when we think that there is a simultaneity, X can affect Y, Y can affect X. We don't know which one is affecting, which one is more powerful, we don't know. But if we believe that these two variables have some simultaneity, not only 2, 3, 4, 5 variables have a simultaneous relation, we don't know a priori which one is dependent and which one is independent. Anyone can be dependent, anyone can be independent. Okay, and you also must keep in mind that when we are specifying a VAR model, we are not saying that A12 or A21 must be significantly 0. We are modeling in this way because we don't know, but it may come out to be 0. So in that case, we can say that xt has 50. If we find that A12, after estimation, we find A12 equal to 0. So at that time, we can say, no, xt has do not have any contemporaneous effect on yt, but yt have a contemporaneous effect on xt. Okay, at that time, after estimation, we can say it. But SIM was against this kind of a priori restriction. Why you are putting a restriction that no, xt and yt has no cannot have any contemporaneous effect? Okay, he was against this idea. So he formulated this kind of model. So axt is equal to beta 0, that is the constants of the two variables, beta 1, that is the coefficients of the lags, and then xt minus 1, capital xt minus 1 is a vector of the lag values of yt and small xt. Okay, and plus the error part. Okay, so this is the structure of the economy we are thinking. We don't know which one is dependent, which one is independent. We don't have any knowledge. So we are actually do not taking any chance to be wrong. So we are actually assuming that both the variables can affect both, okay, simultaneously, and also the past values can affect. So this is our assuming that this must be the structure of our equation. But what you have in your hand, what you can do with your data, you can only have the past values. We have values for xt, a series of xt minus 1, xt minus 3, xt minus 4, all the past values. You have all the past values of y. Okay, so based on the past values, we can easily estimate a reduced form var. What is a reduced form var? Actually, this 80 was actually containing the contemporaneous effect. It is very difficult to capture. You cannot apply Oilless in this case, okay, because you have simultaneity. So remove it. How can you remove it? You can pre-multiply A inverse. So A inverse AXT. So now it is becoming only X. XT means it's a vector. We have two variables within it, YT and small xt. Okay. So now pre-multiply A inverse in all the cases. Okay. So now your beta becoming B. Okay. So actually what is B0? A inverse B beta 0. So the constants you had in your S var, that is the structural var, now we are actually having a linear combination of the contemporaneous effect and the constants of the structural var is now our constant in the reduced form var. You can estimate it very easily. You have the data, and actually the past values, you don't have any you cannot have a simultaneous relationship with the past values. Okay, so you can estimate this. This is what we have estimated. Just we have estimated in the EVUs. Okay, we regress our variables. We had 4 variables at that time on their past values. Okay, so we in our FDI equation, we regress it on FDI's past values, GDP's past values, exports past values, and the domestic credits past values. Now we are having only 2 equations for the sake of simplicity. So we can estimate this reduced form var, and we can use this reduced form var for the purpose of forecasting. Okay, but another important thing we can do with this var is the policy analysis. We can analyze the effect of policy. We can actually estimate the S var through this reduced form var. How? Actually, the problem with these two, that is, we can estimate reduced form var, but finding out this A matrix, that is A inverse, is very difficult. Okay. From the reduced form var, you cannot find directly the A matrix, the A inverse matrix. Because in the reduced form var, you have estimated actually 9 parameters. You have, I think, 1, 2. You find a C in both, in all the equations you have seen that in the last row we have the constant term. So this is here B10 and B20. These are the C's you will estimate. So these, from this you will have 2, and from this matrix you will have 4, so 6, and from the error terms you will find 2 variances and 1 covariance. So ultimately you will have 9 parameters. But with these 9 parameters, you cannot estimate the S bar, because in S bar, that is the structural var, you have 10 parameters. You can count it out. These contemporaneous effects are there. 2. These are the most problematic. So here 2, 3, 4, 5, 6, 7, 8, and 2 variances. In that case, no covariance will be there because they are the independent innovations. So from 9 parameters, you have to estimate 10 parameters. It's impossible. You cannot, until and unless you are actually putting a restriction. And that restriction is putting a restriction is called identification. If you want to identify the structural var from the reduced var, you have to depend on some kind of restriction, and that is called identification. Okay, so now you are only having a excess parameter. Okay, so you have to eliminate one. Okay, you have to make the unknown parameters in the S var to be 9. Now it is 10. You have to make it 1. So you have to eliminate 1. So let us assume that A12 is 0. Okay. This is where theory comes in the var model. So now how can you say it is 0? Now you can say I'm assuming that xt is such a variable, we do not have any effect on yt. You can think in this way. In the second page, we have a very good example. Now, actually, we are estimating where we are presenting a 2 variable case. You can make it 3 variable, and if you are having 3 variable, then you have to put 2 restrictions, because in that case, for the 3 variable case, actually, you have to put probably 3 restrictions, okay? Because number of unknowns will get increased. So you have to put 3 restrictions. Then in that case, you can make the A matrix look like this, where 1 and the first 2 element you are assuming to be 0. For the second row, you are assuming the last element to be 0, and for the third, you are assuming what it is given in that matrix. Okay. Now, what is the theoretical possibility? How can you say it is 0? It is abrupt, you can see. But if you think that we had 3 variables, yt, xt, and z, and now, for simplicity, think yt is representing the price, xt is representing the unemployment and the economy, and zt is the policy rate. You can think of monetary policy. If you know the Phillips curve relation, then it will be easier to think monetary policy. You can also think it of the fiscal policy, whatever. Now, when we are imposing these 2 first restrictions, that is the what these are? Actually, these are the contemporaneous effect of xt and zt on yt. Okay, these were the first equations. So now if you put these 2 contemporaneous effect to be 0, actually you are saying that, or actually you are assuming in your economy, the price is sticky in nature. So price level adjust more slowly. So whenever there is an increase in unemployment or increase in the policy rate, your price in contemporaneously or instantaneously will not react. Of course it will react, but with the lagged effect. Okay. Now when you're saying that unemployment, so in case of unemployment, you are saying that of course it will react, but not immediately to the change in policy rate. With the lagged effect, which will react. Okay. And for the policy rate, you are assuming that yt, xt will have the contemporaneous effect on z. It is the one. It's on its own. So you are assuming that the monetary authority or the fiscal authority to be very proactive. Whenever there is an increase or decrease in the price or unemployment in the economy, they instantly react with their own instruments. If it is monetary policy, they can increase or decrease the repo rate or whatever they can do. For the government, they can increase, decrease, or the tax rate. They can put a ban on the export. Now we're seeing that for the for lot more agricultural products are being banned to be exported. So these are the actions they can take. So whatever you are comfortable, you can think of ZT like that. So these are the restrictions you are putting to identify the S bar. Then you can estimate the S bar. And after estimating S bar, you can have the impulse response function. Okay. So without estimating S bar, you cannot estimate the impulse response function. What impulse response function is? Impulse response function actually says when there is a shock to the economy. Say in the first equation, say yt is the price and xt is the output. So if there is a shock in the price, say the international petroleum price has increased, so it is out of your economy, it is coming as a shock. So how your economy will react? There will be a direct impact on YT, that is the price level. There will be an indirect effect on the output also. Now, if you're assuming that A12 is 0, then you are assuming that it will affect the output with a lag, not instantaneously. And if you're assuming no, 12 is not 0, then you are assuming that whenever there is a shock in the international price, oil price, it will contemporaneously or instantaneously not only affect your price level, but also the output. So this is your assumption. So actually, in general, what usually people do, then when you estimate a VAR, okay, so when you estimate a VAR, you usually estimate an impulse function. It is the impulse, okay? This is the multiple graph, and these are the variables and period that it will show the effect, the effect of a shock up to period 10, okay? So you will have this kind of thing, okay? So the first one is response of the domestic credit to its own credit. If there is a shock in the credit, domestic credit, say there's a loan waiver, okay? So it's a shock. It will come as a shock. So how the domestic credit will react? Now, the next one is how the export will, growth of the export will react up to the period 10 with a shock in the domestic credit. These are the impulses we are talking about. But in this case, you may ask that we have not estimated the S-bar. So how can you estimate the impulse response? Actually, E-views by
Madam lost her connection. Let us wait for a few minutes.
hello.
Yes, madam, you can continue. You lost.
I lost my connection. Okay, okay. So now can you see my screen? No.
No, ma'am.
Okay, now is it visible, the impulse response function?
Yes, it's
Yes, ma'am.
Yes, ma'am.
And was I connected at that time when I was showing that how to measure this impulse response?
No, ma'am. No, ma'am.
No, no. Okay, okay. Let me show you. This was the estimated output. Okay. So now, if you want to see the how the system reacts to a particular exogenous shock, okay, so you have to estimate the impulse. It is called impulse response function. So now you can have the impulse response function in the table format, but it's more easier to see the graphs. So you will have multiple graphs. And impulses, we are assuming that in all of the equations, we're having a particular type of impulse. That is, what happens if in the credit equation or in the credit market, we have a shock, how the credit market will react and the other variables will react. We will find from this impulse. Again, we are having impulse for the ln export, that is if there is a shock in the export growth. Okay, say suddenly we are facing a ban from European Union, that no, we are not suddenly facing a sanction. You can think for the Russia, you can think when they first face a sanction that no, your products are not allowed to enter in our economy. So that is, you can think of a negative shock. Okay, outside the system, suddenly Russia faces a negative shock in their export market. Okay, so how this system, the whole economy will react, we can find out from the impulse response. Similarly, you can have a shock in the FDI and you can have a shock in the GDP, and we can see that responses. Okay, so here we are given all the 4 variables as responses. If you want to see the impulse of the credit, domestic credit, and the responses in the all the 4 markets, all the 4 variables. And if you don't want to see what happens to GDP for the domestic credit shock, you can eliminate. Okay, whatever you want. So these are the impulse response function. Okay, so the first column is for the impulse of the domestic credit. If you have a shock in the domestic credit, how the other variables, we have eliminated GDP, so we have left with the 3 variables. First, how domestic shock in the domestic credit will affect the domestic credit, how a shock in domestic credit will affect the export, and how it will going to affect the FDI. Okay, these are the impulses. Now anyone can ask me that we have not estimated the S bar, so how can you estimate the impulse response? Okay, actually EViews by default estimate a S bar using the Causality decomposition, what we have shown, that is the recursive. Sorry, let me show you the PowerPoint. The recursive decomposition, that is when EViews have 2 variables, you have given EViews the data of 2 variables, it will automatically assume that the A12, that is the contemporaneous effect of X on Y, is 0. Okay, it will put this restriction automatically. If you have 3 variables, it will make the A matrix like this. It will automatically use these calculations in the background, and based on it, it is giving you the impulse response. So you have to keep in mind that whenever you are having an impulse response, you are having a structural bar in the background. And if this kind of decomposition of the A matrix is not going in your theory, you have to estimate by your own a structural bar. So in general, what is suggested that when you are giving data to the EViews for the estimation of bar, you should keep in your mind the ordering of the data. YT, XT, which one is to be the first variable, which one is to be second variable. Because based on the ordering, you will have these restrictions. Because EViews actually, the first variable, EViews assume that YT do not contain any contemporaneous effect of the other variable. It is assumed. Okay. So if you XT, if your YT is such a variable which you believe must have the contemporaneous effect of the other variables, put it in the last. Okay. So ordering of the variable in measuring bar is important because of this underlying Causality decomposition, based on which EViews estimate a S bar, structural bar, and then estimate the effect of these UT, the innovations, on the variable. Okay. So what you have to keep it in your mind that for VAR analysis there is an importance of ordering of the variable. Okay. So first we estimate a reduced form VAR. It's very easy. Just using Oilless you can estimate. And then identification. Identification implies imposing some restrictions, and EViews actually does it through Causality decomposition. Okay, what I have shown you. So then EViews automatically estimate a structural bar, and then from the structural bar, the impulse response functions are measured. But if your system or your variables are not stationary, at least covariant stationary, the impulse responses will not die out. You can see that the impulse responses, let me show you. So it is initially the shock. After the shock, it's moved out, and then ultimately here we have said up to 10 periods, it will dying out. Okay, everywhere you can see. Okay, but if your variables are not stationary, your system is not stationary, system is not stable, then you will not have this dying out effect. It can be explosive. So a particular shock can be permanent in nature. If you have a shock in the domestic credit, your model will estimate such an impulse response, such an impulse function that you are having the effect of the shock in getting increasingly higher over the periods, which is not theoretically plausible. Okay, so you have to make your variables, or make sure that your variables are stationary, so your system is stable. Okay, and important points you should remember that you have to study the lag structure. Optimal lags is to be included. Stability, as I've shown you, that the AR roots, the characteristics roots must lie within the unitary circle, and the diagnostic test as for autocorrelation, that is LM test, normality test, and heteroscedasticity test. Let me very quickly show you how can you test residual test. Okay, so from the parallelogram you can show whether the autocorrelation or not. Okay, if it is a graph, if it is dying out, okay, then there's no autocorrelation, and if you do not understand, you can see that it is dying out. If you do not understand,
is not showing.
Not showing. Okay, let
No.
me show. Yeah, this is the views. Now is it showing?
No, ma'am.
Yes. No.
Yes, ma'am.
Yes.
Yes, ma'am.
So this is the estimated output, and from this the residual test. Okay, from this you can check the diagnostic test, the autocorrelation LM test you can apply. That's to include again. So say 2, 3, or 4, whatever you want. Based, sorry. Lag say 4. Okay. These are the results. Okay, from these you have to check the LM test and the probability. Then for the residual test, use normality check, normality. So the Jagvera statistics from the joint coefficient you should check, and these are the other tests from the residual, the heteroscedasticity, or you need homoscedasticity to be. So these are the tests you should check. But we are running out
for
of time.
heteroscedasticity,
So,
ma'am, for heteroscedasticity, can't we check the individual, whether they are individually homoscedastic or not, instead of checking the overall homoscedasticity?
no, you need to model to be as a whole the var to be homoscedastic, the residuals to be homoscedastic. Okay, you are not checking here the individual for the individual equations. Okay, you have your model should be stable, your model should be homoscedastic or like that. So you have to check as a whole. Okay, residuals, whether the residuals are normal or not, whether the residuals are homoscedastic or not, they are checking it. Actually the calculation behind these are a bit complicated, but you do not have to check for individual equation. Okay.
Okay, ma'am.
So now this is the VAR. Now again going to the PPT. This is our PPT. So now we are coming to co-integration and the ECM. Okay. So when we can apply co-integration? When we have non-stationary data. Okay. If we have two data sets, say for example, for simplicity, these are I1. Okay, most of the time we confront with I1. Okay, so that is you have to differentiate once to make it stationary. These are I1. So if there is two I1 variable and you perform a Oilless regression, it may not always Fourier if the residual from that regression it turned out to be a stationary. Why we're saying that? Because the non-stationary nature of a variable is not spurious, anything spurious. It's its feature. The variable, the time series is of such a kind that it is non-stationary, that is, it is mean, its variance, its covariance are depending on the time. This is the non-stationary nature. Now, if xt is a non-stationary variable and yt is another non-stationary variable, and when we run a regression and the residuals are coming out to be stationary, it means all the non-stationary features in xt is completely explained by the non-stationary features of yt. So whatever is left out is just an error. In that error, we do not have any non-stationary. So with time, that particular error will not increase or decrease depending upon the time. So it's a stable relation. You can have your belief or you can have a trust on this type of relation. Okay, and we call it equilibrium relation because over time there is a stable relation in between these two variables. Okay, so formally we define co-integration as let zt be a vector of variables. Vector of variables mean, let us assume there are two variables. So in the last line is written that in zt you have yt and xt. Okay, and both are id. To make the thing more general, we have written is d can be 2, 3, 4, 5, whatever you want, but in general we face d1. Okay, d as 1. So these are the I1 variables. If these are I1 variables and any linear combination like this is a linear combination between x and y, where the beta is the coefficient, linear coefficients. So any linear combination is coming out to be stationary. That is yt minus alpha minus beta xt is equal to et. So this part is the linear combination, this part. Okay, and what is left out is et. Now if et is I0, that is stationary, then we can believe that the relationship between yt and xt is not spurious. It's the equilibrium relationship, it's the stable relationship, because all the non-stationarity in yt is actually explained by xt. So xt and yt are co-integrated. I can show you from the Enders, the applied econometrics book. Enders is a very beautiful book. You must have go through this. So in that book, it is shown that for how the non-co-integrated variable looks like. You can see that the dotted line is a variable and the thick line is another variable. Okay, these are actually non-co-integrated because they are linear combination, a regression they have done, and the residuals are actually like this. Okay, so these are actually with time somehow increasing. You can show it graphically, and you will also check the unit root test also for these residuals. You can see that these are non-stationary. So using these two equations, if you run a regression like this, the scatter plot and then the regression, it is spurious in nature because the value of the beta we will get actually over time will not stable. Okay, so if now it is saying that for this period it is 20%, the xt is affecting yt 20 at a rate of 20%, it may not true for this period. Okay, in this period the error or explained part of y is becoming something else. But how the co-integrated equation looks like this? The dotted lines, a particular equation is showing, and the thick line is another series. And if you regress this on this, that is this is the scatter plot and the regression. Okay, so if you regress, then the error term will look like this. Okay, it is 0, so it is just fluctuating around 0. Okay, you can have 3 variables, this, and this. Okay, they are any pair of the variables are not co-integrated, because if you run regression on this and this, or this and this, or this and this, you will not get an I0 residual series. Okay, but if you combine these three, okay, ZT, WT, and YT, a linear combination of these three can be I0. That is, the residuals looks like this. So it is fluctuating just around 0. It is not depending upon the time. So this is the concept of co-integration. Okay, I can show you how to estimate this kind of model. So let me again go to the e-views. Let me share it. So now, using this data, okay, I'm showing you. I have another data series, but we don't have that much of time. So delete it. Okay. Delete bar. Okay, we are deleting the. So now let us see whether the export now. Okay, so for Brazil now you can use the Brazil. So let us explain see whether the export of Brazil is co-integrated with the GDP of the Brazil. Okay, GDP. We are assuming that these are I1. I think these are I1, and in this case we need not make this series I0 because we are dealing, but we are learning how to deal with the non-stationary data. Okay, but you must keep it in your mind that these series must be of same order of integration. That is, you can try to find out the co-integration between I1 and I1 series. If you are having I2, then you have to find another I2 variables to check whether they are co-integrated or not when you are using these kinds of techniques. But there is a technique that is ARDL. We will not discuss today, but that kind of technique can take care of these different kinds of integration. But for now, you have to be sure that your series are of same order of integration. So now we are dealing with two I1 variables. One is export of Brazil, another is GDP of Brazil. Okay. So now open as equation. Okay. So let us estimate that assume that export of Brazil is the dependent variable and GDP of Brazil is the independent variable, and simple Oilless regression you can. Okay. So now again you can see that how the R square is, how high it is greater than the DW statistics. Okay, so F statistics very good, but whether it is spurious or not, you have to check. Okay, how can you check? You have to estimate the residuals of the series. If the residual is I0, then we can have a belief that yes, the growth rate of GDP can affect the not growth rate of GDP, the GDP series of Brazil is actually an increase in the GDP in Brazil, which actually have a 2% increase in the export of Brazil. Okay, is it saying, it is showing that? So whether to believe or not, you have to make residual series. Okay, so from this ordinary residual, it will be named as residual 01. I can rename it to remember it's for Brazil. Okay. So this is the residual series we can have from that regression. So now just check whether it is stationary or not. You should always you should not include any intershift or trend or intercept in the residuals, because residual always fluctuates, or it ought to fluctuate around the 0. So intershift should not be there, and of course it must be I0 at level. Okay, augmented decoupleur test you are using, and you can see that yes, it is I0. Okay, so you can have a belief that Brazil's GDP is actually affecting the Brazil's export in a significant way. Okay, this is the concept of co-integration. We can say that the GDP of Brazil is co-integrated with the GDP of, export of Brazil, and they are positively co-integrated. You may have a negative co-integration also. Negative relation actually, negative long-run equilibrium relation means negative co-integration. Okay. So now it is expected that increase in GDP must have an increase in export. Okay. So this is the concept of co-integration. Now, a related concept is the error correction mechanism. Co-integration is a long-run concept. Over the period, what you can observe. Okay. Now, in the short run, you may deviate from your long. Okay. So, how to model the short-run dynamics of a two co-integrated relation is called error correction. And when you have more than one variable or two variables, it is called vector error correction. So, let me delete it. So, how to model? The short run model means the first difference model. Why it is short run? Because you are just concerned with what happened in the present over the past year. What happened in 2021? You just eliminate the 2020 from the 21. You subtract the whatever you had in the 2020. So you are differencing. It means you are just you are interested about what happened in the immediate year. So it's a long short run analysis. And when you have data in their level, you are having the long run analysis. So how to estimate? So make it the first difference. Okay, these are I1. So when you are taking a first difference, it is becoming I0. And you have to include the long run relationship it had in this equation, because it is said that if two variables are co-integrated, that is ultimately in the long run, they are converging. So in the short run, they will have an automatic tendency to maintain that long run relationship. It will, even if there is a force, a diverging force in the short run, there is an automatic mechanism in this system that will actually attract the diverted series towards that equilibrium series. Equilibrium by definition means equilibrium means even if you deviate, there will be an automatic tendency to again coming to that point. So that is equilibrium. So if you have a long run equilibrium, then in short run, you may diverge, but there is a tendency to coming back to that equilibrium equation. So how to measure it? So you put the series. The name of the series was residual. Okay, residual Brazil, but with a lag. Okay, I don't know if -1 will suffice, because for the previous year's lag, you will first see that how much you have deviated from the long run equation. Then you will decide how much to adjust in this period. So we are including a lag term here, and we have a constant and simple Oilless, because all these are I0. We made this series I0 by differencing, and we have checked the residual is I0. So no need to differentiate out. It is already I0. So all these I0 variables, we can simply run a Oilless regression. Okay. So this is the Oilless regression. Now you can see that the short run effect of GDP, or that is GDP growth, on the export growth is positive but insignificant. And what is very important to remember that actually this relationship is not valid, because the residual, it is the ECM term, error correction mechanism. Here the error correction is not going on. Why? Because if the residual is positive, it means residual means the EI. Okay, so in the long run the error is positive, it must be 0, but somehow you have it positive. That is your export, the data for your export is basically higher than what it ought to be if it depends only on the GDP. Okay. So now, if you realize that in the last period you had a higher export than what our theory suggests, okay, that is you have a positive error. What you should do to maintain the equilibrium, we should bring it down. Okay, so these coefficients must always be negative and significant. It is significant, but here it is positive. Means if for a particular period we have a positive error, that is export growth, not growth, that is the export was higher, then in the next period we're again having higher export, but it is not. If you believe that you have equilibrium relation, it should come down. And if in the previous period you have your export was less than what predicted by the GDP series, what ought to be, then in the next period the equilibrium relation actually wants it to be higher. So the coefficient for this error term is always should be negative. If it is not negative and significant, it means your relationship is spurious, or your model you have to re-estimate, or this is not a good model. We have to bring another variable, or these two variables is not having a equilibrium relationship ultimately in the long run. Okay. So this is what given in the slide.
Ma'am, if the variable coefficient of variable comes negative, then the error correcting term should be positive. Means vice versa.
No. We don't have no relation with the first coefficient and the second coefficient. Okay. First coefficient can be positive, can be negative. So you have to explain it according to your theory. So if you believe that increase in the GDP must your export growth must get reduced, then it will be negative. And if you believe that your increase in the GDP must be associated with an increase in export, it will be positive. Okay, these are two things. But so the error correction term must be negative, because if it is not negative, how can you maintain the equilibrium? Isn't it? If a particular period you have a higher error, positive error, okay, so in the next period it must come down. And if for a particular period if your errors are negative, okay, you are having less of the export than what you should be. So in the next period, to maintain the equilibrium, you must increase your export. So relationship must be negative. If it is not coming out to be negative, then you can say your model is not good enough to explain the long run and short run relationship between the export and the GDP. Okay, so these things are here written in the formal terms. So it is delta YT. Delta YT is depending on this. Actually, in that case, whatever I've shown you is a simple regression, but an autoregressive nature must be there. That is YT. Let me show you how it actually looks like. Estimate. No, sorry. So with these two equations, first estimate a bar, okay, unrestricted bar, because from at least one endogenous by bar estimate requires at least one endogenous by. Okay, we're taking this and what was the Brazil GDP? Okay, with these two variables, open as bar. Okay, so this is the result, and from these you have to take the lag length criteria, put it 4 maximum, then see, and here we have 2. Most of the in most of the cases
showing. If use is not showing.
I'm sorry. Let me show. Now is it showing?
Yes, ma'am.
Can you see it?
Yes, ma'am.
Okay. So okay. So we have taken Brazil's export and Brazil GDP, okay, as our variable. In their level, these are I1, okay. we know that we are taking I1 in the var, because in this case, our ultimate motive is not to estimate the var. We have estimated var just to know the lag structure. Okay, what should be the optimal lag? So from this var, go to the lag structure, then lag length criteria, and according to your own judgment, I have given 4 as the maximum lag, and most of the criteria here, now you can see that saying 2 is the optimal lag. Okay, so you re-estimate with the 2 lag, and now vector error correction. Okay, you are estimating VECM. Okay, VEC and M is for the model. Okay, and the dependent variable is again export, independent variable is GDP. But here now, okay, these no need to put the D because they will automatically do. And the co-integrating relationship, here we are assuming that in the model 3, that is intershape, no trend in the co-integrating relation. So in the first model, when we have taken OLS, we have taken only C, no trend. And also in the var, we have a C, intershape, but no trend. Okay, so this is the co-integrating relationship, underlying co-integrating relationship, based on which it will give you the error correction model. Okay, so this is how it looks like. So the first one is the long run equation. Okay, so in the long run, you always keep it in your mind that you have to multiply this coefficient with a negative side. It is negative. It doesn't imply that export and GDP are negatively related. Actually, it is positively related. It has taken all thing in the left hand side, so it is becoming negative. Okay, I can show you in the slide that how actually the vector or the actually it is a vector, how it is written. Okay, so you just now, for now, you keep it in your mind that you have to multiply everywhere. Okay, whenever you are estimating a vector autoregression, EVs will give the result in this format. So you have to multiply the variable with a negative sign. If it is a positive, it comes out to be positive. You have to believe that the variables are negatively related, and when it is negative, you should believe that these are positively related. It is highly significant. Okay, so now,
Ma'am, please repeat again.
okay, the first part, the co-integrating equation. Okay, that is the long run equation measured in level. Variables are taken at their level. Okay, we have not differenced it out. So how in the long run GDP is related to export? It is showing by this coefficient, but you should not believe on this sign. You have to multiply it with a negative sign. Okay, because in EViews they have taken everything in the left hand side, so it is already coming with a negative sign. Okay, so here it implies that GDP and export are related with a positive 2.3%. It is the elasticity because both are log, taken in the log form. So it is positive. Everywhere you get a result, you must multiply it with a negative sign. If in any case you find a positive relation, you should be believe that the relationship actually negative. Okay, I will show you in the PPT that why it is coming as a negative relation. It is just a mathematical notation. There's no need to worry about it. But you keep it in your mind. It is not negative related. It is positive related. Now coming to the error correction, the ECM is showing here. Okay, it is becoming significant. The T statistics is quite high, but it is not negative as we find out. Okay, and the other parts of the error correction is the first difference term. Export is depending on the lags of export and also the GDP growth rate, lags of GDP growth rate. Okay, and it is no, it is not becoming significant. Only the GDP is becoming significant. That is, the short run relation is negative, while the long run relation is positive. But we should not give much importance to this model because the error correction here not coming out to be negative. Okay, but sometimes, or in if your model is good enough or theoretically very plausible, then in many a times you can find a significant relative negative coefficient for the error correction term. You only believe or proceed with the VECM if you find when the ECM as negative and significant. Okay, so now coming to this point, why should we multiply a negative here? It is the PPT. Share it. Okay, and integration. Sorry. Okay, you can see that is the theta. Okay, if this is your equation, when you are actually measuring in matrix form, Z is the first vector containing these two variables, and theta is the another, which is actually the contains the coefficient. So the coefficient of y is 1, and coefficient of beta, x is minus beta. Actually, beta, we're taking it from this side because actually you should put this here. Okay, so it must be negative and it must be like this. This is actually you were measuring. Okay, this is the here minus a. Okay, so this is the equation and this is the real. It should be I0. Okay, so actually the relationship between x and y is beta, but here beta is coming with a negative sign. So that's why in the E views, whenever you have this coefficient, you multiply it with a negative sign. Multiply, not multiply it with a negative sign. Okay. So should I proceed or should I end? What do you want? Actually, we need another 2 or 3 classes to complete the whole thing in a comfortable way. But I think I don't have time. But if you want to me continue, then I can show you some another results where you can have a negative significant error correction term. Okay, I have to find it out whether where I actually got a negative relation between the variables. But this result is also very useful because every researcher must know that whenever we are applying a sophisticated technique in our data, we may not get our desired result. Okay, so you have to think, you have to apply another technique, you have to remodel, you have to include another variable and a more lags, or you have to redesign your data set, redesign your model to have a reasonable result. Okay, not the results you cannot desire. Okay, what actually is you have to find out. So you don't think that whenever we are applying a technique, we will get our desired. We are not here to get any desired result. We want to get an accurate result. Okay, so you keep on trying, redesigning, rethinking your hypotheses, your data sets, your period of time, and we have to. You have to keep it in your mind that in the whole class we have not talked about the structural breaks, but whenever we're dealing with time series data, we must include the concept structural break. We must actually check whether there is a break or not, because with the presence of break, all the estimated results are actually can be a spurious results if you are not taken care of the structural breaks. But here we are not, we don't have that scope to discuss. Probably in any other classes in your FDP, we will some resource person will discuss. Okay,
Ma'am.
And now, yes.
Ma'am, can you please go to the co-integration part, the co-integration equation?
Yes, in the slide or in the
E-views.
In E-views. Yes. Are you talking about this?
Yes, yes.
Or this is the OLS we have measured?
No, ma'am, this one. So, ma'am, if it comes like this, so we can interpret that the BR is having a positive relationship, longer relationship. With
GDP of Brazil
having a positive longer relationship with the export of Brazil. So, ma'am, is there any technique of identifying the long run causality? Like for short run causality, we know the Granger causality. And for short.
Exactly. It's a very good question. Okay, from this error correction, you can say that if it is negative and significant, it means that every time you are diverting, you have a tendency to revert back to your long run relation. So you can think this as your long run causality. But here we do not find any such kind of causality, isn't it? So actually we check long run causality through these ECM terms. We can check, we can interpret in that way. Okay. Actually, as if to check the short run causality, you use Granger causality. Formally, we don't have any such causality test for long run, but the ECM can be treated as a long run causality test. If it is coming out to be negative and significant, we can say that there is a long run causality between GDP and export, because every time these two series are getting diverted, they have automatic tendency to coming back to that particular relation. So in the long run, they are trying to maintain that particular causal relationship. So you can think it as a type of long run causality test. Very good, very good. I forgot to tell you.
Ma'am, if the co-integration shows 2 or 3 equation, then all the 3 equation has to be negative and significant, unless we cannot say there is a long run causality, or if anyone comes negative or significant.
And then you can say that we have a long run causality in between only for those variables, not for the other co-integrating relation actually is not valid. You are having that kind of relation at the first time you are having to say we have 4 variables, and you have and the co-integration test, the Johansen co-integration test, in that case we have to use, and you are same. Let me show you. So cancel. Let me show you what happens. For the Brazil, okay. So for Brazil, we are taking another 2 variables. Okay, and what another Brazil? Yeah. Okay. Now open as no, sorry, not system. Open as group ID. Open as group. Now co-integration test. Okay, and Johansen co-integration test I am using this time. And actually this model 3 is the in general we take, because in model 3 we are assuming that there is only intershift in the co-integrating equation and also in the VAR. Okay, so it is more plausible, but you can also check the other. You can see all the results together. That is, summarize all the 5 sets of assumption. You can include exogenous variables also here, but I'm not going to those complications. So these are the results. So actually we were to take this model, intershift and no trend. Okay, the linear intershift, of course, and the trace and max eigen statistics. These are the statistics from which we can identify whether there is any co-integration or not. We are finding there is 2 co-integration. This method is showing 3, this method is showing 1, whatever, but you can also find which model is to be taken. So you can find it out the lowest value. Okay, so you have to find the lowest value of these information criteria. Which one is lowest is very difficult for now. So let us assume, you can find it out from this, but let us assume this model is the best model. So, and or at the first hand co-integration test, we have used only this. Okay, because this is the most plausible one. And here we are assuming 1 lag, but again in this case also you first have to estimate a bar, and then from that bar you should find out the optimal number of lag. But I'm not going to that detail, but you should do whenever you are doing an original research. So this is the equation, and trace indicates 2 co-integrating equation as they have shown, and max eigen indicates 2 co-integrating equation. Okay, so now if you want to estimate VECM, auto regression, you can see what happens. Estimate bar from this vector auto coefficient. Okay, and here they are taking 2 lags, so I'm not changing it. So
Ma'am, co-integrating equation.
Cancel. Sorry, the co-integrating these are the number of co-integrating equations. So from this, we can estimate VECM, isn't it? It is the co-integration test, and then the var. Where should I go? I think from this. I think. Group statistics.
Estimate var.
Estimate var. Estimate var. Okay. So vector error correction. Huh?
And co-integrating equation.
We have to include all the variables. Okay, we have to write it down. So ln export of Brazil space ln GDP of Brazil, ln FDI of Brazil, and another was ln D domestic credit of Brazil. Okay. And the co-integrating underlying co-integration, they will automatically select these two co-integrating relation and based on the model 3. Okay.
But ma'am, our co-integrating equation was 2, so don't we put 2 over
I can
there?
show you. Okay. Okay. Yeah. Okay. So they are first ln export was taken as an dependent variable, and the others are the independent variable. Now you can definitely include the two relation number of co-integration. Okay, make it 2. You have 2 equations. Okay, so this is the first co-integrating equation, this is the second co-integrating equation. Okay, and the error, now you have 2 error correction. Each variable is actually trying to maintain the first one and the second one, but from this you can see that the export, okay, the short second co-integrating equation. Okay, so it is positive, it is significant, but it is positive. So actually this co-integrating equation is not valid.
Ma'am, the internet connection was poor. Can for the first co-integrating equation, it is hello. Hello.
Sorry, I got disconnected. Now can you hear me and see my screen?
Yes, ma'am.
Okay. So you have 2 co-integrating equation. So now for the export, we can say that export is trying, that the short run export is trying to maintain the first equation, because and each time it is correcting itself by 25%. Okay. For the GDP equation, it is negative but not significant. So GDP is not trying to maintain that equation, neither the other equation. And you can see the second equation, second co-integrating equation is not valid actually. Okay, because neither variable in the short run trying to maintain that equation. Everywhere it is positive, and in most of the cases it is insignificant. The 2 of the cases insignificant, and in 2 of the cases it is coming out to be significant. So you can re-estimate the model by eliminating the second one. So number of co-integrating equation is 1. Then what happens? Also, the importance of the second co-integrating equation is here, because in this case, what we are finding that again the export is not correcting itself to maintain the long run relationship. Probably this we should keep the second one or delete the first one. Okay, or we have to eliminate a particular variable from this relation. Let's see, if you eliminate say abruptly, say eliminate GDP, or domestic credit. What should we eliminate? Let us domestic credit be deleted. I don't know whether I'm doing right or not. Okay, based on this one and only one. Let us see what. In this case, we can see that in the short run, the FDI is trying to maintain that co-integrating relationship with a speed of 15% in each year. But for GDP equation, it is coming out to be negative, but not significant. And for export, it is positive and not significant. Okay, so you have to re-estimate in this way. And actually, these 4 variables are not sufficient to make a VAR model. It is a VAR model. We seen as a part of VAR, where we can actually extension of VAR, where we are measuring. But because the second part, this part is a VAR. Okay, and this is the underlying co-integrating relation. So actually, to make a VAR, you should be careful enough to in choosing your variables. It must not include an important linking variable. It must exclude the otherwise extra variable. You should not keep it in keep. So my suggestion is to make a model, actually with a meaningful model, with a plausible underlying theoretical relation, and then try to re-estimate these things. So you will get good result to explain. Not good I'm not saying good means that desirable, but that can be explained. In here, these models you cannot explain actually meaningfully because of the abrupt selections of the variables. Okay, and also you can see the R squares are very low. Okay, only for this equation the R square is good, that is 59 or 60%. And in this case also you are having a significant, that is FDI. So with these variables you can explain FDI good better, but other 2 variables are not very good fitted for this model, isn't it? So now have you understand that how should we proceed? We have a lot more things to do or a lot more things to learn.
I'm sorry to
But,
interrupt.
yes. Hello?
Starting at 5 minutes, madam.
Yes.
Madam, we have another session starting at 5
Okay,
minutes.
okay. I'm sorry. Okay. So all the participants, I can just say you that if you have doubts, you must have doubts. So you please mail me. Okay, you can have the mail ID with the organizers. So you mail me. I shall definitely interact with you in a later period. Okay. I'm sorry.
Thank you, ma'am.
Okay.
Thank you,
So, okay, sir. Thank you. Thank you,
madam, for your wonderful deliberation.
Okay, sir. Thank you. Okay.
I quickly request Sentulal ji to provide the instructions to madam.
I, on behalf of the organizer, thank Dr. Sudipta Jha, madam, for sparing her valuable time and making available for this session. It was very interactive. We are thankful for your GDP concept and educating us how ordering of the variables is significant for measuring bars. The very short session, but very impactful. Madam, we hope and look forward to have more sessions in near future. I thank all the participants for cooperating in the session. Without you, all this session would not have been a successful one. I would like to thank also to Dr. Dibjyoti sir for trusting me and giving me this opportunity, and hope and pray that you will remember me in the near future when you organize like this or even more bigger workshop and seminars. Thank you all. I now hand over this session to the organizer. Sir, it's over to you, sir.
Thank you, madam, once again. And I give you advance welcome for future occasions so that we would like to listen to you in future too, madam.
Okay. Thank you very much. Okay. So I'm leaving. I'm sorry. I have taken more time than what was scheduled. So I'm sorry, and I'm leaving. Okay.
Yes.
Very absorbing session, ma'am. I'm Sanjeev Sharma.
Yes.
Sir is our next resource person, next session resource person.
Sorry.
Professor Sanjeev Sharma.
Sudipta ma'am, we will continue to trouble you at Punjab University also.
Sir,
you are wonderful. I listened almost half of it. Sorry, I could not join earlier because we have our classes till 5:15. So immediately I rushed and joined your session. It's a wonderful session. Great.
Sir, I'll convey the message. She left actually.
Oh, okay. It's okay.
Sir, after many days, I'm seeing you, sir. Sir, actually.
How is the program going, doctor?
Program was going very fine, sir.
Oh, great, great.
Almost
great.
you have
I
covered
could,
70% of the
yeah,
program.
I could see a lot of familiar faces. Vicky ma'am is there, and Vishali, and so many, Swati ma'am. So many of them were there in my programs also. So good to see them. Good to, right.
Sir, can you just give 2-3 minutes break for the participants?
In the meanwhile, if you permit, just to save time, can I start sharing my screen so that we save time?
Sir, you
others can have a break. You can please have 5 minutes break. You can go and prepare tea in case you want. It's an afternoon time, so it's raining very heavily here in Chandigarh. So,
sir, it's the common news from everywhere, sir. Raining heavily.
Yeah. This time we have 130% rain, almost right. Okay, great. So give me a time, Doctor, because I'm not very familiar with the Zoom.
Sir, you can do one thing. You just test the sharing of the screen by the time.
I'll do it. Just give me a minute. Is it okay?
It's coming, sir. Yeah, it's fine.
Great.
You can just make it full screen so that we can.
That I will. It's okay now?
Yes, sir. Fine. Perfect.
Great. My dear colleagues, you can have 5 minutes break. In the meanwhile, I'll chat with Dipjyoti, my old friend. Doctor, have you got some sponsorship for this workshop?
Not exactly, sir. We are doing it in self-financing. But
Okay.
the good thing is that we are in a collaborative FDP. 2 universities are participating. Vidyasagar University, West Bengal, and our university, Assam University. So, like both of we are organizing the program.
Okay. Otherwise, next time, now you please apply to ICSSR, Indian Council Social Science Research. They give a lot of funding for such research projects and programs. And now even the window of UGC is open. So in case somebody wants to apply for.
We find that nowadays less importance is given to research methodology, but more in artificial intelligence and some other topics. Because
no, Doctor, no. ICSSR is very focused. If you send a proposal to them, they'll be more than keen to finance it.
No, I'm telling about the AICT ATAL programs, because this time also I applied to the same research methodology topics. Like I don't know why they might not have preferred it.
Participants are from all disciplines. I could see some from economics, some from
economics mostly.
Mostly commerce and business management. Huh?
And they are from 25 states out of 28 states.
Oh, wow. Great. That's great. That's great. So I should skip those with the engineering and medical background. Am I right? They're not much from them. No?
Not much familiar to this.
Because if I start sharing the research funding agencies, they run into hundreds. So I need to curtail myself into only those which are prominent and where most of the people stand to gain. So that will be my focus.
Sir, you'll be happy to know, like since we started this program on 5th September, that was Teachers' Day. So in most of the session, what we are doing is that we are dedicating each of the session to a kind of personality of India, great personalities or a great teacher of India. And then we actually start the session by introducing the resource person. So for that, I think we have to again stop sharing from your side, and then again we'll start sharing from your.
Sure. It was just to try, because I'm not very familiar. So I will stop this sharing. Okay, give me I'll pause share. It's okay now.
I'll do that.
It's okay now.
Yeah, now it's okay, sir.
Fine, great.
So I think we can start, sir. It's almost 6:30.
Whenever you want, I'm ready.
So I formally welcome Professor Sanjeev Sharma, sir, who is from University Institute of Management Sciences, Punjab University. He's a professor there, and most importantly, he's a very wonderful person. And he is a regular resource person in most of our FDPs in Assam University. And the topic that I have chosen, he is an expert in that field, and he has also taken the same topic in the earlier FDPs also. So I request Sarojini ji to do the initiation of the session.
Thank you so much, Dipjyoti sir. Am I audible?
Your voice is low.
Sir, am I audible? Sir?
Yeah, little, not exactly fine, but little. Can you increase the volume or?
Yes, I have done
Yeah,
that,
now
sir.
it's okay. Now it's okay. Yeah.
Yeah. Thank you so much, sir, for giving me this opportunity. A hearty welcome to one and all to the 2-week faculty development program on research methodology and applied econometrics for social sciences organized by the Department of Business Administration, Assam University, Silchar, in collaboration with Vidyasagar University, West Bengal. I take this privilege to welcome all the participants, the dignitaries, our beloved and respected teachers, and our esteemed and honorable speakers to light up with their knowledge and valuable insights to the 9th day of this FDP program. I also feel extremely honored to have with us for today's second session, Professor Sanjeev K. Sharma, who is a professor of University Institute of Applied Management Sciences, Punjab University, Chandigarh. Thank you so much, sir, for joining us for today's session. But before introducing Professor Sanjeev K. Sharma, I'd like to take a few minutes to dedicate this session to one of the renowned personalities in the field of education, freedom struggle, and women empowerment. She is none other than Sarojini Naidu. Sarojini Naidu was an Indian political activist, an educationist, and a poet of immense stature. She was a proponent of civil rights and activist who fought for India's freedom as well as raised her voice in favor of women education and empowerment. Sarojini Naidu was born on 13 February 1879. She was born in a Bengali Brahmin family in Hyderabad. She was a meritorious student who excelled in the field of education. Naidu passed her matriculation to qualify her university study, earning the highest rank in the year 1891. From the year 1895 to 1898, she studied in England at King's College, London, and then she studied at Girton College, Cambridge. With a scholarship from